Hello, today we're going to talk about what limits are in an introductory video. Limits are a topic in calculus that allow you to develop the concept of a derivative and the concept of an integral. Limits in of themselves are just a tool. They're a bridge. They're kind of like subtraction. Subtraction is something that is not super interesting, but it's useful for other things, and limits are kind of the same thing for as far as calculus goes. So that's why we have to kind of have a good understanding of limits before we can do any real calculus concepts. In this video, I'm going to talk about very generally what a limit is. In subsequent videos, we're going to talk about how to evaluate hard limits and different techniques for and rules for limits, but this is simply a very rough introduction of what a limit is. So I'm going to write down a function, and I'm going to write down lim. We're going to say as x goes to 1. I'm going to write the function x squared minus 2, and just do equal like that. So this is just the most basic limit that you might find. And before we dive into what I'm talking about here or what we're doing, I'm just going to evaluate this using what's called direct substitution, where I just take my 1, I stick it into the function 1 squared minus 2, and that limit is equal to -1. Now, that's a very easy thing to do, but it also taught you nothing about what a limit is or why it's important. So I'm going to leave this on the top of the paper. We're going to draw a graph, and we're going to delve more into what a limit is and why it matters. So for starters, I'm going to draw this graph, at least a version that's good enough for us to work with. Here's -2. We'll do x is 1, y is -1, x is 2, and y is 2. Well, should be good enough for us. 2. Okay, that's my graph. You can see this is 2, 1, so forth. So a limit is about what happens to the y value as x gets close to a certain x value. In this case, it's 1. So think about a limit, first of all, as simply a question. I'm going to write that question down. What happens to y if x approaches 1 from the left, or x approaches 1 from the right? So on the x-axis, the two ways we can approach a number is from the left and from the right. When I approach a number from the left, sometimes you'll see a little minus sign up at the top. And when we approach from the right, we have a little plus sign. So that's what that notation means. Let me just draw on this picture an example of approaching from the left and the right on the x-axis. And we're dealing with 1. So I'm going to just come up here and say, I'm approaching from the left and going towards 1 that way. That's approaching 1 from the left. And then if I approach from the right, I'm coming in this way. So when I approach from the right, it means I'm coming from the right towards 1. As I approach from the left, I'm coming from the left towards 1. And so when we approach the x value 1 from the left, what a limit wants to answer is what happens to my y value. And so the y value tracks this curve. And you can see the y value is kind of coming up just like that from the left. And then as x comes from the right towards 1, my y value is kind of coming down right there towards that same value. I'm going to put a circle around it. It's coming down towards the point -1 right here. And that's the value that I got up here as what my limit is. So the first pass at what a limit is you could say, y does this if x does that. if x goes to 1, what does y go to? And the catch here is a limit is never going to be explicitly about the point itself. What happens when x equals 1? I don't care. I have no interest in that, and all it has nothing to do with the problem. A limit is about what we call the neighborhood around a point. So, and that's going to be a crucial concept when we deal with calculus, is we may not actually want to talk about a particular point itself, or more importantly, we may not be able to talk about a certain point itself, but we sure can talk about what happens if we get really close to it. That's what a limit's all about. Let me draw another little picture here for you with a different function. So we'll just kind of move down here. This time I'll do a linear function. We'll do limit as x approaches 3, and we'll have the function negative 2x plus 2. And this function you can evaluate with direct substitution. If you take 3 and you plug it in for x, negative 2 times 3 is negative 6, plus 2 makes that limit's negative 4. Okay, fair enough. But let's draw a picture and let's talk about it more in the sense of what the neighborhood around that point is. So we're going to start with an intercept of 2 right there. We have a slope of negative 2, so we'll go down 2 over 1, down 2 over 1, down 2 over 1. And you can see that this graph looks kind of like that. And hopefully you can see the hash marks. This is x equals 3. And then my graph here is that's negative 1, 2, 3, 4, 5. This is where am I? Should be 1, 2, 3, down 2 over 1, down 2 over 1. There we go. Down 2 over 1. Draw that again for you. There's 2, and so we had the function negative 2x plus 2, and point there, down 2 over 1, down 2 over 1, down 2 over 1, and this is 1, 2, 3. And we'll just go down 2 over 1 again. There's my line. Okay. So I told you that the limit as x went to 3 of negative 2x plus 2 was equal to negative 4. I'm going to circle the neighborhood again here. This is x equals 3. So if you come down here and I put a little circle right around that point, that region around the point, not the point itself, is my neighborhood. And you can see that if x comes this way from the right towards 3, my y value does this. It goes up towards the point negative 4. 1, 2, 3, 4. And if my x value comes from the left towards 3, then my y value follows along this this line, and it also approaches that same point, negative 4. So the limit's negative 4. In a subsequent video, you'll learn that both sides have to match. That's one thing that's essential for a limit. But for now, I just want you to know that a limit is simply what happens to the y, roughly, when x roughly does fill in the blank. When f roughly gets close to 3, what does y roughly get close to? Negative 4. as I said, this is a really easy kind of limit to do. It's called direct substitution. And the reason limits are hard, it's not because they're conceptually hard. It's just because there are certain kinds of limits that are difficult to evaluate. So for now, I'm going to leave it right there. We will spend more time dealing with how to deal with certain limits in future videos. Bye-bye.